How do probabilities change when you get new information? This is conditional probability. The key question here is, what are the odds of something happening if you know something else has already happened or is already true? And the key word is actually the word if. Let's start with an example. 52 cards, a deck of cards. So we shuffle the deck. There's 4 queens. So the chance of drawing a queen is just 4 out of 52. That's a basic probability question. But what if we change it just a little bit? Let's say just before you decide, is this card a queen, you receive one little bit of information that the card you have picked is definitely a face card. Right, so now I'm telling you it's 100% a face card that you've drawn. So it has to be a jack, a queen, or a king. That's the new information. So given what we've picked is a face card, we're going to zoom just on those face cards, just the 12 face cards that we have. The ones, the aces, the twos, the sevens, they're all gone. We're just looking at a much smaller set of possible cards. Now, these are the 12 possible cards. This is what we call a sample space. Remember that from the last one. So our sample space has gone from 52 possible cards all the way down to just 12. Now, given that we're looking at a face card, what's the probability that it is a queen? Our whole universe is shrunken down to 12 cards, so it's 4 out of 12. That's our new probability. And the key thing here is that word if or given. Right, let's quickly cover some of the main vocabulary that we've discussed here. First of all, conditional probability. It's the probability of an event happening given or if another event has already happened, so we know something else to be already true. It's written as P A given B. And we also need dependent events. So the second event, drawing a queen, was dependent on whether or not the first card, whether or not we already knew that it was a face card. In joint probability, both these things need to happen. It needs to be a queen and a face card needs to have been drawn. So here's the formula. And for the most part, the formula is not as important as your intuition. So keep that in mind as well. Right, so we're looking at this a little bit. It has to be A and B. It has to be a queen and a face card. So both things need to happen. All right, so let's look at this formula with a different type of problem. So we can just use percentages instead, make it a bit more generic. So here we've got some people. We asked them a survey question about what type of movies they like. So 50% of the audience is female. The second thing we know is the probability of someone who is female and likes action movies is 15% or 0.15. That's 15% overlap between the two groups. So here's the question. Of females, or given it's a female, if it's a female, what's the probability they like action movies? So our universe has shrunk once again. We're down to only talking about the females. So what is the probability of A, action, and F, female? 15%. That's the joint probability. The given part, the given probability is female, so that's 50% or 0.5. So now we just have to divide that joint probability by the given probability. So that's 15 out of 50, which is 30%. So 15% of the total group, but then we're only looking at the females, so it's 15% of that 50%, which comes out to 30%. So the chance doubled because the sample space halved. Right, so what are we looking for? How do you recognize that this is a conditional probability question? And the key sign is that little word if or given. It could be written other ways, but that's the main two words that you'll be looking for. All right, so can you think of an example in real life where the odds change when you get some new information?